continuing from our dot product, we were looking at the properties of our dot product. And the first one is going to be quite simple. If we have a dot b, it simply equals to b dot a. All right. And I think it's quite obvious from our definition of the dot product. So, I mean, let's say we have a as a1, a2, a3 dot b1, b2, b3, which equals to a1, b1, a2, b2, a3, b3, right? And we can actually just rewrite this as, well, b1, a1, b2, a2, and b3, a3, and that just simply equals to b dot a, right? So that is the proof. Of course, you can look at the mod a mod b cosine theta as well, where it's actually the same angle. So that's why b dot a is the same thing. Another property, actually again, comes from the definition, is if you're to dot the same product, or rather the same vector, it actually gives you the square of the magnitude of the vector. And again, it comes from the definition of the dot product, where we now have mod a, and now cosine 0. Alright, so cosine 0 we know is 1, mod a is simply mod a square. So the third one again comes from the definition of the dot product. If we have two vectors and that equals to 0, this implies that a is perpendicular to b. Alright, and again it comes from the definition, right? Mod a mod b cosine theta, for it to be 0, assuming that mod a and mod b, they are bigger than 0, then it implies, or it automatically follows, that cosine theta is the one that is 0. And because cosine theta is 0, theta equals to 90 degrees or pi over 2. Alright, so that is the whole idea behind. Now, the following properties actually kind of show that the dot product, and in fact, as well as the cross product, the one next product we're going to learn, actually kind of follows like standard multiplication ideas in our algebra. Alright, so let's say we have a plus b, vectors a plus b dot c. This simply equals to, well, it's actually the rainbow method, but instead of having just AC, because that makes absolutely no sense, you need to have a product. So dot product remains as dot product, so a dot c plus b dot c. And the proof very simply comes from the definition, right? a1, a2, a3 plus b1 plus b2 plus b3 dot c1, c2, c3. Alright, then you can just break it up, right? So do you know that this equals to a1 plus b1 times c1, and then we notice that from here we can just break it to a1 c1 plus b1 c1. Same thing for a2 c2, b2 c2, a3 c3, b3 c3, and realize it's basically a dot c plus b dot c. Alright, so this is the proof of property number 4. On a similar note, if we have a plus b dot vector c plus d, then it's really just a standard expansion, right? So we will do a dot c plus a dot d, and then plus b dot c plus b dot d. Alright, so the same thing, proof will come from this. The sixth property, and well, it's not really much of a big problem. If we have a dot kb, where the k is a real number, it can be positive or negative, it simply equals to ka dot b. Alright, so it's like multiplying by a scalar constant where we bring k to the front. Alright, so this kind of brings us to the fact that if, let's say, we have a plus b dot c minus d, then, you know, we just need to be careful. It's going to be a dot c plus a, rather, minus a dot d, because, you know, a dot minus d equals to minus a dot d. Alright, and then so on and so forth. So we have plus b dot c minus b dot d. Alright, so this is a rather important property, whether is it minus 1, whether k equals to minus 1 or k equals to 2 whatsoever. Alright, so these are the 6 properties. Of course, the last one I think is pretty trivial. It's just if a dot 0 vector, we know that it's simply 0. Alright, because mod b in this case is mod 0 is 0, or you can look at it the other definition, where b1, b2, b3 are 0, so you automatically become 0. Alright, so I'm just going to leave that out, and these will be the 6 properties that you need to know for the dot product, and come in very handy when you're tasked to prove equations or try to prove that related to the dot product, be it from the expansions that you might need, especially property number 5 and 4, and even from the definitions that we learned in the previous video. Alright, so in the next video we'll look at an example, and I'll see you guys soon.